follows. Bronchopulmonary dysplasia is a major cause of infant morbidity and mortality in the U.S. There are 14,000 new cases per year, and despite new advances in perinatal and neonatal care, the incidence remains unchanged at 30% of infants that weigh less than 1,000 grams. The only currently acceptable preventative therapies are vitamin A and caffeine. So, what is caffeine? Caffeine is a methylxanthine that blocks adenosine receptors. And here I have a little schematic of the receptors on adenosine. Adenosine can have either excitatory or inhibitory actions on these receptors. Caffeine has been shown to decrease the incidence of BPD as compared to placebo controls, and it has been shown to reduce inflammation, primarily in TNF-alpha, in newborn mononuclear cells in vitro. So because of these properties that caffeine has, our hypothesis was that caffeine will decrease inflammation and reduce alveolar hypoplasia during hyperoxia exposure. So our experimental design was that we set up 2 dams in hyperoxia and 2 dams in room air. We normalized in each of these 2 groups so that we had a N of 6 for each of the 2 dams in room air and N of 9 for each of the 2 dams in hyperoxia. We exposed the hyperoxia groups to 80% hyperoxia, and we exchanged the mothers between the caffeine groups and the saline groups in and out of hyperoxia on a daily basis to reduce any oxygen toxicity. The level of caffeine citrate that we administered to these caffeine-treated animals was a load of 20 milligrams per kilogram intraperitoneally on postnatal day 1, and we continued until postnatal day 15 with a dose of 10 milligrams per kilogram intraperitoneally for every day after the first day. So we collected bronchoalveolar lavage fluid. We also collected the right lung for RNA analysis, and we collected the left lung for histological analysis. So all of our results will be shown as the mean plus or minus the standard error of the mean, and asterisk indicates a p-value of less than 0.05. So the first thing that we looked at was the weight gain in 2 different groups, and you can see here, this is the room air group. The black here indicates the saline treated, and the green indicates the caffeine treated. You can see that the caffeine treated had poor weight gain in the room air group, and here you can see the hyperoxia group, red indicating saline, yellow indicating caffeine, and you can see the same pattern where the caffeine group had inferior or had worse weight gain. So the next thing that we looked at was our PAL collections, and we noticed that both in at postnatal day 3 and postnatal day 15, that we had increases in the number of neutrophils. So PN3, we had a significant increase in even the room air group for the caffeine-treated animals, and at P15, we had a significant increase in the hyperoxia for the caffeine-treated animals. So in order to sort of help back this information up with some mRNA analysis for inflammatory markers, we looked at CXCL1 mRNA expression, and it's a neutrophil chemoattractant. And we noticed that there were significant increases not only in the room air group, but also in the hyperoxia group. So we wanted to next look at to see if whether this inflammatory impact would also impact the morphology of the lungs. So we noticed that caffeine actually worsens alveolar hypoplasia in hyperoxia, analysis using radioalveolar counts and noticed that in hyperoxia, the caffeine seems to significantly decrease the number of alveolar counts. It's not marked here, but these differences in hyperoxia also are significant compared to the Lumiere controls. So in order to see what differences in cell types, whether certain cells were decreased, we did a stain for alveolar type 2 cells, and we noticed that there were actually decreases both in room air for the caffeine-treated animals and also in hyperoxia for the caffeine-treated animals. We also did some mRNA analysis and noticed that at room air, there were significant decreases in the mRNA level of SPC, and there was, at the very least, a trend in the hyperoxia group for mRNA levels. So in order to provide maybe some sort of a mechanism for this, we looked at cell apoptosis. And the immunofluorescence stain actually, we could visibly see that there were marked increases in the number of cells that were seen positively for apoptosis. And our quantification for this also showed similar findings, that we had significant increases in apoptosis in caffeine-treated groups, both in room air and in hyperoxia. So due to these findings, we showed that caffeine reduces